Okay, hi everyone. This is going to be the problems video for chapter 5. We have a fair amount to do here, maybe 6, 7 problems. Some of them are quicker, some of them are longer. So let's start here with exercise 5.1. Right, it looks like they're giving us a corporation's contribution format income statement for the recent month. Right, we can see that because it's sales minus variable expenses gets us our contribution margin, and then you backed out your fixed expenses to get you to your net income. And they want to know 3 different scenarios here. Right, the first one says, what would be the revised net operating income if the sales volume increases by $100 or 100 units? The second one says, what happens if it decreases by 100 units? And then the third one says, what would be the revised net income per month if sales volume is 9,000 units? Okay, so we saw like a similar setup to this in the PowerPoint when we were looking at the contribution margin and how it affects net income. So as a starting point, right, this is where we're at, right? The first scenario we have to do here is for 1, where what's going on here is in 1, we increase our sales by 100 units. Okay, so we're going to have a total column here, and then we can do it on a per unit basis. But in this way, right, we're going to have our sales, right, as our first line item. And here's the deal, right? We have 10,000 units in the original. So in this one, we're going to have 10,100, right? So this is going to be 10,100 times $35 per unit gives us 353,500. Okay. We know next we have our variable expenses, right? That looks like that's $20 per unit. Okay, so we're going to do, in this case, the 10,100 of sales times the $20 per unit. It's going to get us 202,000. That amount is going to be our contribution margin, right? So if we do our sales minus our variable expenses, we're at 151 on a per unit basis, right? We're still at $15. We got to then back out our fixed expenses, right? So if those are fixed, they're going to remain unchanged, right? So in this case, it's 135,000. They're fixed. And when we do the 151, our contribution margin minus the fixed expenses, our net income, or our net operating income, is going to be 16.5. Okay, so we went from 15 to 16.5. In other words, if we increase it by 100 units, our sales, if this guy goes up, our net operating income goes up. Another way you could get this, right, is you could take your original income, right, the 15,000 from over there, and then what you could do is add to that the change in the contribution margin. So in this case, what that would be, right, is 100 additional units with a $15 contribution margin per unit, get you 1,500, right? Same idea, you're still at 16.5, right? This is just an alternative way to get there. Okay, so we've looked briefly, we say you increase the sales, you increase the contribution margin in that case, which increases your net income. All right, same thing for 2, except we're decreasing sales, right? So to save us a little bit of time here, because some of this was formulas, right, we decrease our sales by 100 units. Right, so our sales in this case, right, we went from 10,000 and we lost 100. So we're going to be at 9,900 in this case times the 35 bucks. There's 364,500. Again, 9,900 times the variable expense per unit. Looks like our contribution margin is going to be 148.5, which gets us to a net income or net operating income of 13.5. We could do this as well if you wanted, right? It would be the original net income. But what we would do here is, right, it would be the 100 units times the $15 margin, but we have to subtract it in this case, right? Both get you to 13.5. So in short, right, if we decrease our sales, we decrease our contribution margin, and we decrease our net operating income. Okay, that was 2. Let's look at 3 here, right? The idea on this case is what would be the net income or the net operating income if you sold 9,000 units, right? So again, we can, in this case, just copy this down. So it's going to equal 9,000 times the 35, 315, equal 9,000 times the 20, 180, we're at 135. Oh, check it out, right? This is 0 down here. In other words, if we sold 9,000, right, this would be our break even point, right? That's exactly where, at the end of the day, we break even. We're at $0 of income. We don't make money, but we don't lose money, okay? So this is just an example of illustrating, like what we've seen in the PowerPoint. Increase sales, increase the contribution margin, increase net income. Decrease sales, decrease the contribution margin, decrease net income. And then you have that middle point, right, where you're going to break even, where there's no gain or loss. Okay, let's look here at E5.2, right? So in this case, it wants a cost volume profit graph, and then it wants a break-even point in units. But let's look at the original facts. Okay, so it says Carleak Enterprises distributes a single product whose selling price is $24 a unit and whose variable expense is $18 per unit. The company's monthly fixed expense is 24 grand, right? So the first thing we're going to want to do when we look at one here, it says prepare a CVP graph for the company up to a sales volume of 8,000 units. Right, so we can do one together, and I'll just post the graph over, but essentially if you look at the PowerPoint, right, we have step 1, step 2, and step 3, if you were to put on a graph, cost, volume, profit analysis. And basically the first thing you want to do, right, is draw a parallel. This is a accounting class, not a spelling class. That's like one thing if you are in practice, just a practice tip, some people don't know this, there is spell check in Microsoft Excel. So if you go into business, if you go into accounting, sometimes I just type incorrectly, or I have made up things in my head, but that's the word parallel. So we got to draw a line parallel to the volume axis. And basically, we're trying to show our fixed expenses, right? And then the next thing we're going to do, step 2, is choose some volume of sales and plot that point where you're going to show total expenses, fixed and variable. So here we're doing this for 8,000 units because that's what it says in the prompt for one. And then the third step is going to be choose some volume of sales and plot the point representing total sales dollars at the activity level. Right, so again, here, 8,000 units. So we want fixed expenses, right? Draw a parallel line across. Then look at our total expenses based on an activity level of 8,000 units. And then look at our sales dollars at an activity level, 8,000 units. So here's the graph, right? We could draw this, we could do it. The idea with this is you're going to have step one right here, right, where you do that fixed expense, right? Then step two is choose some volume of sales and plot that point, right? So if we go down here, our sales revenue is the triangle, right? So here's going to be the sales revenue, step two. And then step three is, in this case, I'm sorry. Let me go back. Looking at that graph incorrectly here. Step two is we want the total expenses, right? So that's going to be the square down there. They should color code these things, right? They almost look like exactly alike. They're so small. And then step three, right, the sales revenue. And again, we can see this is at the $8,000 of activity level. All right, so this is just showing that. The next thing they want to do here, right, is they want us to estimate the break-even point in units, sales using cost, volume, profit graph. Okay, so the idea here is, right, whenever we do step two, and it's a little bit hard to see on here exactly, right, because these are like broad ranges. But in step two, the idea is when we picked 8,000 units, the result of this will be 168 in expenses, total expenses, of which 24 are fixed and 144 are variable. Right, so step two, right here, here's the 24 that are fixed, and then the 64 that are variable, or the 144 that are variable. And then for step three, right, when we did the 8,000 units, let's just say that resulted in 192,000 of revenue. Right, that's where we are up there. Okay, so with these facts, right, we're going to try to do the break-even point in this case. One of the things that we want to say here is the break-even point, right, that's the point where total sales revenue and the total expenses line intersect. Right there, right? And the idea with this is, right, if we were to think about it, there's a couple ways you could do it. But here's the idea, right? One of the ways we've learned, the equation for the profit is the unit contribution margin times the quantity minus the fixed expenses, right? So in this case, it looks like our unit contribution margin is going to equal, right, we have 24 minus 18 and times the quantity of 4,000, right? That's where we land up right there. then from that, right, we're going to back out our fixed expenses of 24,000. Right, the idea is when you do that, the profit equation here, you're going to hit 0. Right, the idea is this is break even right here. And the idea with it is that's at 4,000 units of sales. Okay? So, and this is just showing you the idea of it. Okay? So, in this way, right, this is just an example of it, showing you it in graph form, and then using an equation to help us determine the break-even point. Obviously, there are the equations that are the true break-even point, but this is just an alternative way of calculating it, getting you to the same end result where your profit's going to be 0, right? All right, so now let's look at break-even point, using those traditional formulas. All right, they're giving us some information. It says a company distributes a single product, a basket, whose selling price is $15 per unit. It has variable expenses of 12. The fixed expenses are 4,200. All right, first one they want is break even in unit sales. Second one they want, right, is break even in sales dollars. And then the third one they want here, right, they want, it says if the company's fixed expenses increase by 600, what would become the new break-even point in unit sales, in dollar sales? Okay, so they want us to do a variation here for 3. We'll get to that when we come to it. Right, so leveraging this equation, right, if we were to populate this in format, we want our profit here to be 0, right? Because that means we break even. We don't have a gain or loss. So if we were to fill this in, right, it would be the unit contribution margin, which is the $15 minus the 12 of variable expenses, okay? And then from that, right, we would have to figure out the quantity sold in this case, right? So the idea here with this is we have, so let me map this out down here to show it to you what's going on, because it's a little bit harder in that formula, all right? We have our unit contribution margin. $15 minus 12 times the quantity, right? Minus our fixed expenses of 4,200, right? So we're trying to solve for the quantity, right? We have all of the other variables. When you do this, right, you rearrange the equation. It's just simple algebra where you solve for it. Q is going to equal 1,400. And just to show us that, right, if we did 15 minus 12 times 1,400 baskets we sold minus 4,200 in fixed expenses, will be at $0, right? We break even in that case. All right, so the break-even point in sales dollars, the idea here is all you need to do is take your unit sales to break even. Okay, so unit sales to break even. We know from up there That's 1,400. The sales price per unit, right, they give it to us is $15. So there we go, we're at $21,000 in sales. In other words, based on these facts, if you want to break even, you have to sell 1,400 units, or stated alternatively, have $21,000 in sales units. Or, I mean, in sales dollars. Okay? Three, the idea with this is they're changing it, so they're saying the fixed expenses increased by 600. Okay, how does that change it? All right, all we have to do here is repeat step 1 and 2. Okay, so it's going to be the same formula up here. So our profit, we're going to have $0. It's going to be, again, our 15 minus our 12 times the quantity minus, here it went up by 600, so it's going to be 4,800. Right, 42 plus 6 is 48. The idea here, when you solve for the Q, when you rearrange that variable just using simple algebra, you're going to get 1,600 baskets. And then if you do that 1,600, so this is in units, and if you do that times the $15 selling price per unit, you're going to have $24,000 break even in sales dollars. Okay, so pretty straightforward. You know, a lot of this chapter is just kind of plug and chug. It's learning about why are we using these equations, what are they for. But if you can do just things like memorizing these equations and are able to plug it in and solve for a missing variable, that will be 3/4 of the battle for this chapter. All right, the next one here, target profit analysis, right? It says Lynn Corporation has a single product whose selling price is $120 per unit and whose variable expense is $80 per unit. They have monthly fixed expenses of $50,000. Okay. What they want here is target profit, right? So this is going to be a similar setup to break even, but instead of having like 0 in there for the profit that we desire, we're going to just plug in that amount, right? So the first one is, based on those facts, what do we need to sell in units to have a profit of $10,000? Okay, right? So profit is going to equal our unit contribution margin times the quantity minus fixed expenses. Looks like here, right, we sell it for $120. We have $80 of variable expenses. Our desired profit is $10,000. Times the quantity minus our fixed expenses of $50,000. Right, the idea with this is if you rearrange this guy right here using simple algebra, Q, the quantity, is going to be 1,500 units. Right, and let's just show this once, like over here, just to show you like more specifically. Sometimes people do like to see like the algebra with it, which is fine, but sometimes to just be more efficient, right? So what you would do in this case is you would do, first you could simplify it, right? It's going to be 10,000 equals, this will be 40. All right, you solve for this guy right here, times the Q minus 50,000. Okay. Then what you would do in this case is you would move the negative 40 over here, as well as the Q, right? So it would, and you could, in this case, move the 10,000 over as well. In other words, let's start shuffling the deck here, right? So this is going to be 40, move that over to the left side. Times Q equals 10,000 plus 50,000, and then from there, right, Q is going to equal 60,000 divided by $40. Q equals 1,500. Right, if you just wanted to see kind of the long algebra on. In any event, right, the 2 here, it says, can you calculate the dollar sales needed to attain a target profit of 15,000? Okay, so we're just going to do the equation again, right? 15,000 equals 120 minus 80 times Q minus 50,000. Okay. And the idea here is when you do the algebra, Q is going to equal 1,625 units. Right? But they don't want it in units. They want it in dollar sales. Right? So all we need to do then is multiply this times the selling price of $120 per unit. It's going to get us $195,000. In other words, if we want a $15,000 profit based on our fixed and variable expenses and our sales, right, we'd have to sell $195,000 in dollar amount. All right, let's look at E58 here. It says the corporation is a distributor of sun umbrellas used at resort hotels. Data concerning next month's budget appear below. All right, so we have a selling price, a variable expense, some fixed expenses, and unit sales. All right, in this case, they want the margin of safety. Okay, so what's going on here is in order to do this, calculate the margin of safety, the first thing we have to do is calculate our break-even in unit sales. In other words, the margin of safety is going to equal your sales minus your break-even unit sales. So first thing we got to do is solve this over here, right? It's like an equation within an equation. So this will be 1, and then we'll focus on 2 afterwards, right? So 1. So we just had been working with this, right? We know that it's going to be our profit, which we want to be $0, equals our unit contribution margin times the quantity minus our fixed expenses. All right, so we're looking for break even, which means we have 0 over there. Based on the information they're giving us, it looks like we sell it for 30 and we have variable expenses here of 20 times Q minus the fixed expenses of 7,500, right? When we rearrange that and we solve for Q, it's going to be 750 units. And the idea with it, right, we then have to multiply that, so that's in units, but up here it's in sales. If we look at it, break-even unit sales. So sometimes they say this, right? When they say unit sales, they mean sales dollars, right? So on the exam on the homework, it'll be very clear. It'll say sales dollars or units. I don't know why they do this where they put unit sales. It's like, combining 2 and 1. It will be very clear on the homework, very clear on the exam which one I'm asking for. So here, right, we have 750 units. And the idea with it is it's going to sell it for how much if we go up there? $30 per unit. Right, so let me pull up my calculator real quick. So we have 750 times 30. That's going to get us 22,500. Again, this is break even in dollars, sales dollars. Okay, so minus 22,500. And the idea in this case, right, over the budgeted amount, the sales over here, our budgeted amount, are going to be, in that case, 1,000 units times 30, right? That's going to give us 30,000. 1,000 times 30. So our margin of safety in this point is going to be $7,500. Okay, because this is the margin of safety in dollars. It looks like in B here they want it as a percent, right? So all you do here is you're going to take the margin of safety in dollars, right, the 7,500, in this case. And let's see here. You're going to divide it by, in this case, the sales of 30,000, the budgeted sales there. That's going to equal 25%. Right, so let's just do a quick run through here of how we did this, right? They're asking first for the margin of safety in dollars. To get that, it's going to be our budgeted sales, or our expected total sales, minus the break even in sales dollars. We then had to go down here and calculate that break even in sales dollars down here. But to get that, the first thing you have to calculate is break even in sales units. Right, so we did it in units, we said it's 750 in that case, and then in dollars, break even in dollars is 22.5. Okay, so there's the 22.5. We back out the sales of 30, right? The $30 times the 1,000 we expect to sell. 30 minus the 22.5 gives us the 7,500, our margin of safety in dollars. Oh, we zoomed in there. Then they want the margin of safety as a percentage, right? In this case, right, you're going to take your margin of safety in dollars, carry it down, divided by your budgeted sales there of 30,000. In that case, we're going to have a 25% margin of safety as a percentage. All right, let's look at E59. So this one here, right, they're telling us a company, they install lawn sod in home yards. Company's most recent contribution format income statement is as follows. Okay, we can see it breaks out sales, variable expenses, fixed. They want to know what is the degree of operating leverage, and then using that, estimate the impact if there was a 5% increase in unit sales. And then 3, they want us to verify our estimate by constructing a new contribution income statement for the company, assuming a 5% increase in unit sales. All right, so let's do this one at a time. All right, so first thing they want us to do is the degree of operating leverage. Right, and that's going to equal, in this case, our contribution margin divided by our net operating income. All right, so in this case, right, our contribution margin is 48,000. We see that right over there, okay? And then our net operating income is 10,000. We snag that right from over there. Accordingly, our degree of operating leverage is going to be 4.8. Just plug it in the information there. All right, 2 says, if we had a 5% increase in unit sales, what will the effect be, right? So what we would do here is we would take the degree of operating leverage, right, the 4.8 that we just calculated, we would multiply that times 5%, right? And that will give us 24%, which essentially this 24%, this is going to be the estimated percentage increase in net operating income, right? So basically we're just evaluating kind of the sensitivity of, hey, if you increase the sales percentage, how much are you going to, in turn, increase your net operating income? And in this way, we have to utilize that degree of operating leverage. All right, 3, they want us to verify this, right? So I'm going to do this, just type it out. It'll make it a little bit easier. All right, so we're going to have our sales in this case. And we can do it by the amount. And then we can have it as a percent of sales. So in this case, right, if we had originally 80,000 and we increased it by 5%, right, now we're at 84%, 84,000, right, and that's 100% of our sales. Now, of that amount, right, our variable expenses, we know over here, based on this guy, it's a 40-60 split, right? 40%, 60%. So if we did the 84,000 times 40%, right, we're at 33.6. If we did the 84,000 times the 60%, right, we're at 54 there for our variable expenses. Oops. And then our contribution margin. Our fixed expenses, right, they're fixed. They're going to always remain the same, 38,000. In this way, right, our net operating income is going to be 12,400. So at the bottom here, how we can kind of tie this out and prove it, right, we have our net operating income from change of sales, right, 5% change. If we increase our sales by 5%, we're going to have 12,004 operating income. We have our original operating income from up here, right, the 10,000. The difference between those, right, the 2,400, that's going to be the change in operating income. And if you were to do this, you know, as a percentage change in operating income, what you would do in this case is you would do the 2,400 divided by the 10,000. There we go. We're at 24%. That ties out right up here. 24%, 24%. That's kind of how we prove it out there in step 3. All right, let's look at P519 here. Problem 519. All right, so this guy, it says last year a company introduced a new product and it sold 15,000 units at a price of $70 per unit. The product's variable expenses are $40 per unit, and its fixed expenses are $540,000 per year. Couple things, right? They want us to calculate here, 1, what was the product's net operating income or loss from last year? 2, they want to know what is the product's break-even point in unit sales and dollar sales. 3, it says assume the company has conducted a marketing study that estimates it can increase annual sales of this product by 5,000 units for each $2 reduction in its selling price. If the company will only consider the price reduction in increments of $2, you know, 68 down to 66, down to 64, etc., what is the maximum annual profit that it can earn on this product? what sales volume and selling price per unit generate the maximum profit. And then 4, what would be the break-even point in unit sales and in dollar sales using the selling price that you determined in requirement 3? And why is the break-even point different from the break-even point in requirement 2? All right, so that's a mouthful there. Let's take these one at a time. All right, so let's start with 1. They want to know what was the product's net operating income or loss for the last year. Okay, so what we would do here is we would have our sales, right? That's our starting point. And it looks like we sold 15,000 units at $70 per unit, right? 15,000 times $70 per unit. In that way, right, we're going to be looking at 1,050,000 in sales. Then we got to back out our variable expenses, right? It looks like they were $40 per unit. When you do the math on that, it's going to be 600,000. So our sales minus our variable expenses, we're going to have a contribution margin of 450,000. Then we back out our fixed expenses. Looks like that's 540. Right, 540,000. In that way, it looks like we're going to be at an NOL, right? A net operating loss of 90,000. Put some brackets around that. So we're in a losing position right here. So the idea is with 1, let's highlight that we just did it. We did, based on those facts, we figured out that we were at a net operating loss of $90,000. All right, 2, they want to know what's our break-even point in unit sales and dollar sales. Okay, so they want 2, they want break-even in units and in dollars. So, another variation of this break even, the unit component of it. So break even in units. So again, we were doing it the one way. There's another way you can do it as well, right? It's going to be your fixed expenses over your unit contribution margin. So if we plug this in, right, our fixed expenses are 540,000, right, from down here. And then our unit contribution margin, so on a per unit basis, right, it looks like it's going to be, we sell it, let's go over here, right, for 70 per unit, and then 40 are the variable, right, so 70 minus 40. When you do the math on that, right, it's going to come out to 18,000 units. Okay, so that's in units, but they want it in sales dollars as well, right? So if we sell each one for $70, right, 18,000 times 70, that's going to be in dollars 260,000 in dollars, right? So we just did 2. They figured out what is the break even in sales. So we have it in units, and then we have it in dollars. All right, 3. From this, right, we could do 3 in this case. Let's not worry about it. It's a little bit, long and complicated for purposes of this. Let's move on to 4, right? So 3, we're just going to skip. It's a big, long draft in that case. But the answer from this, right? So let me just pull over the answer to show you what it would be. Right, so here's 3. And what they're doing here, could we have typed this in? Sure. Do you want to sit here and watch me type in, 100 numbers? Let's look at it and see what's going on, right? So it says, assume the company, it had the marketing study, and it says it can increase its annual sales of the product by 5,000 units for each $2 reduction in selling price, right? So for every $2 you bring down that price, right? You bring it down, $2, $2. You go up in sales by 5,000. Okay, and then it says, if the company will only consider the price reduction in increments of 2, what's the maximum annual profit that it can earn on this product? What sales volume and selling price unit generate this maximum profit? So in other words, you kind of just do a what-if scenario for each incremental interval here. You compare, the number of units you sell with your total net operating income. And the basic idea here is you're kind of finding that point of equilibrium, the best overall point where you will have the most net operating income in light of what you're selling the product for. So in other words, just because you sell it for the highest price doesn't mean that you're going to have the most income. In fact, it's the opposite here, right? If you sell it for the highest price, you're going to be at a loss. If, however, right, you look at all of these, the highest or the maximum in this situation is this 270, right? That's the biggest number over here. So what that means in this case is at our maximum profit, we would sell 45,000 units for $58 each, right? So this is just showing you when you're looking what to charge for a product and you have some information based on kind of a sensitivity analysis based on change in sales price reflected in change in purchases. Charging the highest price is not always the best situation. In the same way, right, charging the lowest price won't help you either, right? $56. Then you start to go down here, 260 equals 260. The best, right, kind of the winner here, where you have the most profit, is when you charge $58. All right, so we need that information from 3, so we can highlight it here. I put the X. We did it, but we didn't do it, right? Could I type all of those out? Yeah. Do you want to sit here? No. 4 says, what would be the break-even point in unit sales and dollar sales using the selling price that you determined in 3? Okay, so based on this $58 selling price, we need to figure out our break-even. And again, all we're doing is, because it's break even in units, right, we can use that kind of secondary equation. Either one will work, right? If you use the profit equation and you set it to 0, or you can do the kind of true, as it were, break even in units. It's going to be your fixed expenses over your unit contribution margin. So in here, right, your fixed are your fixed. They're fixed, right? Always 540. The unit contribution margin in this case, it looks like it's going to be $18, right? 58 minus 40 equals 18. So in this way, right, we're looking at 30,000 units to break even. But if they want it in sales dollars, right, which I think they do ask for, all you do is you multiply it in this case times the $58 selling price, right? And that will get you 1,740,000 break even in dollars, right? The last little item here, it indicates, it says, why is this break-even point different from the break-even point that you did in requirement 2? So in other words, why is the break-even point here 30,000 units at 100, at this amount in dollars? Why is this different than this guy up here? Like, shouldn't they be the same? Well, the idea is they're not the same because we changed the circumstances, right? In other words, the break-even point is different from the break-even point when we did the one above because we changed the selling price, right? When you change the selling price, what happens there is the unit contribution margin, it's going to drop from $30 above to $18. So when you lower the contribution margin, what that results in is an increase in the break-even point, right? So in short, right, you lower the selling price, lowers the contribution margin, increases the break-even point. That's why we went from 18,000 to 30,000. Or stated alternatively, 1,260,000 in dollars to 1,740,000 in dollars. So with that, right, you can go back and look at these examples, look at the PowerPoint. Chapter 5 is meant to be a little bit of a break, catch your breath, right? We've just been through 4 chapters. This is a little bit straightforward. It's a little bit easier to understand than like a whole process cost system or a job order system. The equations themselves, right, I would make sure to memorize, know them, know how to calculate them using that profit ratio versus maybe the traditional break-even ratio, and know the interrelationship between them, right? So in other words, when we looked at that margin of safety, that kind of had built into it the ratio otherwise, right? So let's see if we go back there, right? So the margin of safety has built into it a second ratio you need to know, the break-even in unit sales. And again, all of this rolls under the umbrella of cost volume profit analysis. Why are we doing it this? Like, what's the 5-minute kind of quick summary here? We are trying to help managers, right? This is a managerial accounting. We're looking at internal users. We are trying to help them make decisions. Like, what type of products, what type of services do we want to offer, and what should we charge for those? In cost volume profit specifically, right, we're trying to estimate how our profits are affected by a change in selling price, a change in volume, a change in variable and fixed costs, as well as what are the mix of the different products we sell. If we start changing things, how does this affect our profit? That's the idea of cost volume profit and where they're going in this chapter. So with that, I'm going to end the lecture here. We will see you in the next video that comes after this one. So have a good day. We'll see you soon. Thanks.